So on many problems, you're going to be asked to graph a polynomial function. So remember that a polynomial function is in the form ax to the n plus bx to the n minus 1, on and on, plus some constant at the end. And you're going to be asked to graph this function. Now, you've already worked with graphing polynomials of degree 2. Those are parabolas. But let's talk about how to graph any polynomial. So the first thing you want to think about is n even or odd? N, of course, being the highest power of x, in other words, the degree of the polynomial. And you want to think about if it's even or odd because that tells you the end behavior of the function. If n is even or n is odd, we get two different results. N is even means the end behaviors are the same. So the limit as x goes to infinity or negative infinity, actually let me rewrite that. The limit as x goes to infinity is equal to the limit as x goes to negative infinity. You can see this on a graph by saying the end behavior of the polynomial either goes like both up or both down. If n is odd, then these two are always the opposite. So the limit as x goes to infinity is the opposite of the limit as x goes to negative infinity. So either it goes down to the left and up to the right, or up to the left and down to the right. The next thing we want to think about is a positive or negative. A is the leading coefficient of your polynomial. So if a is positive or negative, that tells you which specific cases of the even and odd that you have. If a is positive, let me write that here, a is positive, so that tells you that the limit as x goes to infinity is infinity, which means the graph goes up to the right. If it goes up to the right and it's even, then it obviously also goes up to the left. If it goes up to the right and it's odd, then it's going to go down to the left. So if a is positive, you know exactly the shape of these two things. And as you might have guessed, you have exactly the opposite if a is negative. The limit as x goes to infinity is negative infinity, meaning the graph falls to the right. If it falls to the right and it's even, it also falls to the left. If it falls to the right and it's odd, then it goes up to the left. So now we know our complete end behavior of our function by just determining whether n was even or odd. The next thing you want to determine is where the zeros are. So what you need to do is factor the polynomial. Now occasionally, if it's a second degree polynomial or maybe even a third degree polynomial, factoring it can work by your typical methods of reverse foiling or factoring by grouping, those types of things, maybe the sum or difference of cubes. However, if you have a larger polynomial, you're going to need to do synthetic division by thinking about what could be the possible factors of the function. So let's think about what that means, possible factors. So the possible factors of a function are going to be plus or minus the factors of y, where y was our constant at the end. So whatever your constant at the end is. Keep in mind, if your function doesn't have a constant at the end and everything is an x term, you can factor out an x and make it so that that's automatically 1, 0. Plus or minus the factors of y over the factors of a. A is the leading coefficient. So let me just write up a quick example here. 2x to the 5th minus x to the 4th, and I'll have plus, let's go with 10. So my y is 10 and my x, or my a is 2. So I could have all possible combinations of 1, 2, 5, or 10 on the numerator, and 1 or 2 on the denominator, plus or minus. Those are all possibilities. You can see 1 is always going to be a possibility for any of them, because you can do plus or minus 1. Here we could also get 2, we could get 5, we could get 10 if we divide them by 1. Or we could get a half. 2 over 2 is still 1. 5 halves, or 10 over 2 is 5. We already had that. So all of our possibilities here are plus or minus 1, 2, 5, 10, 1 half, and 5 halves. Those are your possibilities for zeros by taking any combination of those factors, and of course any of them can be plus or minus. So you would do synthetic division with this and try some of these numbers until you get some that work. Remember that when you do synthetic division, once you do the synthetic division once and you get that one was a factor, you can just use the resultant coefficients and not have to start with your original function again, because it'll make your life simpler because it'll reduce the degree. So let me point out what that means. Say you had your synthetic division like this, and we had A, B, etc. with K. If you get that one of these was a factor, remember that that means you'll end up with 0 as your remainder. Whatever is left here, the coefficients that are left at the bottom, you can pretend that's what you're going to use to test another factor. So once you have all those things, you have n behavior and you have all your zeros, it's time to just put that on the graph and see what that would look like. So then all you need to do is place any of the factors you got. All of those are going to be zeros of the function. So wherever you happen to get them, place all of your zeros on there. You know what the n behavior should be. So for example, if we had up and down, the last thing you want to think about is, were these the multiplicities of these zeros even or odd? So that's the last thing you want to think about. Multiplicity of the zeros. So that means when you were doing your factoring, did any of them have a power of more than 1? If you have any even multiplicity, it's just going to touch the 0, whereas if you have an odd multiplicity, it's going to cross. So let's say this was A and this was B. So if we had something looking like this, x minus A squared, and our factor with B was just x minus B, we would know that A, our 0 of A, has a multiplicity 2 because our power is 2. That means it's even, which means this has to touch and come back up. It can't cross the axis. However, x minus B has a power of 1, which means that's odd. So when we cross through B, it has to cross through because we had an odd multiplicity. Once you've gotten all the multiplicities, you can simply just draw a line that fits through the zeros and has the correct n behavior. And that's how you graph any general polynomial.